So we'll record this session and we'll post the recording as well as the slides afterwards, partly so that you can go back and look at it again for reminders of information, and partly because we're a global industry. We have teams from all across the world, and for not everybody is this a great time zone. So quick run through what we'll talk about today. So we'll start out, we'll meet the committee who is organizing the event, and we'll talk a little bit about what is a student cluster competition and what it's like, what to expect. We'll go into a few more details about what's happening, particularly in this year's contest, some notes on how to prepare and things that we have lined up to help you prepare. And then to finish off with, we have a new component of the competition this year, which is the NDACC. So our NDACC chairs will tell us a little about that. And then we'll go into the Q&A session. So to begin with, an event like the Student Cluster Competition doesn't happen automatically. It gets put together with a lot of work by a lot of dedicated volunteers. And I'd like to introduce a few at least of the team to you here, especially our leads. So Kathleen is our chair of the Student Cluster Competition and the SCC this year, and she's supported by Stephanie, who is the vice chair. We have a new component in the competition this year, which is the NDACC, which is being co-chaired by Awa and Darshan, and you'll meet them shortly. Some important elements of the competition are applications, infrastructure, cloud infrastructure, and what happens there on site and in person. And so Yassi is leading our applications preparation. Rigo is leading the infrastructure. Andy is looking after our ability to use Azure, and I'll lead for that. And Sam is our on-site lead. So for those who are in the in-person competition, he'll be there overnight at the event. So if something happens, he'll be your go-to person. There is a whole host of other people helping out and leading various parts. So Tapasia and Dan will lead the Power Cap component, which is also a new element of this year's competition. We'll talk a bit about them soon. Limai is leading the reproducibility challenge, and will lead the posters and lightning talks section, supported by Ben, who will tell us a little bit about that shortly. And a number of others of us, including myself, the one on the left here, will be helping out in various ways along the way. More of our team who's helping out with various elements of the competition, and a special call out to our Scalar volunteers who will be monitoring the communications channels and helping you with all sorts of things. So what is it? So SC stands for supercomputing, and its name has broadened a little from the old days when the whole conference was called supercomputing. So its name is now the International Conference for High Performance Computing, Networking, Storage, and Analysis. It has a somewhat broader charter, and it happens every November. So this year the dates are November 14 to 19, and it will be held in America's Center in St. Louis in Missouri. Okay, but what's a student cluster competition? So HPC, you may be aware, is used to solve complex problems in many areas of science and engineering. And in fact, it's seen a little bit of prominence in the last year or so because it's been a significant contributor to the fight against COVID and the development of vaccines. Cloud-based HPC has also been seeing increasing adoption. So cloud for your general computing services has been big for a long time. And over time, the ability to do HPC on the cloud is increasing and as a consequence, increasing in popularity. So an interesting headline came out just a few months ago that I think it's the UK Met Office, the next machine will be a Microsoft, provided by Microsoft, and it will be accessed via the cloud, or used via the, as a cloud sort of system. So that's some pretty exciting stuff. So the student cluster competition exists to provide an opportunity for students to be introduced to HPC as a field, as an industry. It's an opportunity to build some skills and to connect with other students and HPC professionals. Okay, but what actually is it? So traditionally, the student cluster competition has been going since something like 2008. So we've been going for more than 10 years now. And traditionally, it's a 48-hour non-stop contest to physically build and run a admittedly small supercomputer, but a supercomputer, a cluster, within the constraints of a power budget and with some real-world issues to deal with, such as recovering from a disaster. More recently, as cloud computing and cloud-based HPC has become more important, the SCC and BSCC is also a contest to deploy and use cloud-based HPC resources for a HPC workload within a money budget. So this year, teams have a couple of options. There is a physical SCC or a cloud-based BSCC, virtual student cluster competition, elements of the competition. For all of these, students will go through designing your architecture, deploying your clusters, either physically or virtually, running a bunch of benchmarks, kind of ranking your cluster, if you like, that's part of the scoring, and then using HPC resources to meet the demands of real scientific computing applications. So these are not toy applications that we've picked up. These are real applications that get used for real science all of the time. And they're important, and they're what professionals use for research. And finally, reporting on your results. So what's it like? I think some people here, it's not their first student cluster competition, and you'll have some pretty good memories, I hope, of times past. For others, it's a whole new world. So we had a chat with a few past participants to tell us a little bit about some of their experiences. So we have a video coming up where we speak to Sophia and Max and Jacob, who were competitors for variously Wake Forest and UC San Diego teams, and team advisors for those two teams, Sam and Mary. I spoke with Sophia from the Wake Forest University team and with Max and Jacob from the University of California at San Diego teams, and their respective advisors, Sam and Mary, about their experiences last year. Can you tell me, what was your most memorable moment in the SC20 competition?
Well, I think it's still like during the competition, because last year was a little bit special because we did all the things virtually. So we had a room that we spent 3 days in it. And during that 3 days, we not only focused on our own applications, we also collaborated, we helped with each other.
So part of the competition is that we have this mystery application. And so it was mini Vitae. And so we had to get this graph traversal algorithm to run on the nodes that we had. And we had a selection of nodes that we could pick out earlier. And actually going through there and being able to apply sort of what we were doing all along with prepping for that added excitement of actually doing it now for real was pretty cool. And like making a list, checking all the different compiler options. And so a lot of coursework was relevant to that, which was really neat since taking a lot of computer architecture coursework. So with different optimizations and such that you can do, you can kind of see how they correlate, and seeing all that sort of come together here for this mystery application and seeing it work so well was really exciting and really cool.
So I was really enjoying the process of preparing for the competition. For example, I'm working on the reproducibility challenge. So I really did a lot of background research and literature review on 3D reconstruction and how our parallel system helpful in this field.
As the team advisor, what was your most memorable moment during the SC20 competition?
I had a lot of memorable moments, but I think my biggest one was actually during the competition once it started. And it was on day one or late in the evening of day one when I saw that the team just got it. They got what the experience was all about, team synergy, the action, the quick thinking, and they were all working together and getting more and more cohesive over the time that we prepared. But it was at the competition I could see that, yeah, these guys are going to make it.
So Steve, as you know, the primary advisors and also the secondary advisors are not allowed to help the team in any way during the competition. So for myself and the other secondary advisors on our team, we were looking at basically the scoreboard and hitting the refresh button over and over and over and over, just to see like how our teams were doing and how everyone was doing.
How much HPC experience did you have before signing up to the competition last year?
As part of the Supercomputing Center, there's this training that gets put on. And you go through the sort of steps of running on a scheduler, so with Slurm on SDSC's supercomputer. There's also some coursework related to computer architecture, which, as I mentioned earlier, was necessary for that last 1 to 5%, but I would consider that relevant HPC experience too. And that's pretty much the experience we had before we started working with Azure.
We had a class called HPC. So before that class, I had absolutely no experience with HPC, and I did not even know Linux. And I was really struggling at the first because I was really confused. It is totally different from what I have learned in computer science before. Well, before it's more theoretical things and also programming languages. I mean, after taking the HPC class, it's even beneficial for some of my other CS courses. Doing this course is really helpful and it's really practical. I would say it's more practical than some of the CS courses I've learned.
I have more experience with the system in general, but not HPC. 19, I was at SC19 for the volunteer program. So I do have some exposure to the to HPC, but I won't say those backgrounds are very technical.
And so this was a very, very big learning experience. It's definitely a huge learning curve for anybody who's doing this for the first time. But although everyone struggles at the very beginning, everyone eventually gets to a place where they start feeling comfortable.
How would you say the competition has impacted your career and academic path?
So one of the pretty good result is that our team is now working on the publication. So as you know, that there is one part of the competition that is a reproducibility challenge, and we are going to write a critique about one paper from the last year's supercomputing conference. And working on this is actually my first ever experience with the very formal publication process. And especially, I know the journal, the journal the critique is going to be published on is a very formal one. So we actually need to work with different reviewers, and we need to really think of the words and really care about the layout of the paper. And also, now HPC kind of becomes one of the go-to concept. The reason I'm saying that is whenever I'm learning some new concept, I really want to see, how can HPC help about this concept, and how about let's parallel this algorithm. Is it possible to speed it up even further? Or how is it going to perform when we have large-scale data, something like that?
So it gives you a lot more context with regards to, let's say, the research I'm doing in a research group is looking at persistent memory. And so that isn't really found that much in your commercial space, or you don't have any exposure to it. However, you might actually see something like this in a large memory Azure instance, for instance. The computer architecture classes are, for the most part, in your computer consumer system, not really important, but here you get the application of it. And so it's more of a solidification and it's a very useful experience to have when talking to people at internships and such as well about, well, you're able to talk about this in the actual context of deploying it or seeing something actually happen instead of this abstract terminology which you get in the coursework. Usually. One of the most practical computer engineering experiences you can have.
I'll give an example because I'm doing like research involving like deep learning recently. And even now, like while I'm doing research, we're using cluster a lot and we're using like different applications, and I have to install and to like encounter a lot of problems. And I really feel like my HPC experience really helped a lot with this process. I'm not sure if like my future goal will be directly related to my HPC experience, but I'm sure that like this experience will certainly be beneficial to like my future career, whatever I do in the future.
So our students have gone on to a number of different academic and also industry fields, and they've reported back how saying and they tell me, oh, you know, the stuff that we had learned here, I need to do this at work, and there was nobody else who was able to do this, but I'm able to do this, and so they asked me to do this, and so this is of course very rewarding to hear.
And finally, what advice would you give to a team preparing for their SCC this year?
Practice a lot, but also do it with a budget. So we had a spreadsheet which allowed us to track everything, and so this will be different if you're doing in person or virtual. But for the VSCC, we tracked all our costs and had our expected costs for each application, and we were able to use this when they changed it by giving us more budget at the end to see which applications we can now add on. And without sort of knowing, first of all, how long one of these would take, we wouldn't have been able to make those estimates. And second of all, without having these tools to track our current usage, our predicted usage, and all this, we wouldn't have been able to adapt as easily.
Here, I feel like the most important thing is to learn from each other, learn from the team members, and also advisors, and also even like team members from other teams. So I feel like that's more like really a pleasant thing to do, like in addition to actually like competing with each other.
I would say don't panic if you don't have any previous experience. Also, one of the tip I want to give to other teams is to try to automate everything. For example, I was running a bunch of scaling experiments for my reproducibility challenge, and I'd have a run script for each experiment. So only thing I need to do during the competition is to run the script, and you do need to keep a log of error. So once there's error message, you go back to your log and see, oh, I've seen this 2 months ago, and I know exactly what was it about.
Start early. As a team leader, I get as many mentors as I can involved to help maybe spearhead one of the application areas, because it does take a village if you can get it. And the first thing though is to make sure you're having some fun. It really doesn't matter what your final score is. It's great if you got a high one, but what matters is that you got there, you're in the competition, and you do your best and have fun.
So there's a taste of what to expect. And thanks again to Jacob, Sophia, Max, Mary, and Sam for giving us those stories and tips. So I think we should be back to our main slides now, and hopefully what you're seeing is the slide with the Q&A. So this year we have some additions and some adjustments to the formats. And so Kathleen, our chair, would you like to tell us a little bit about the new changes to with the SCC, VSCC, in the setup?
Yeah, thanks, Steve. So this year, kind of trying to be prepared and make sure that we can have teams participating still from around the world. we've separated the SCC into 2 competitions. There's going to be the SCC that's in person, and teams will be traveling to St. Louis for that one. We are required to do fewer physical teams because we're trying to just in case make sure that we're able to have distancing and any other restrictions that are needed. And it will be like a traditional SCC, bringing your own cluster, building it, and running there. We're also going to be holding a virtual VSCC this year, and that will be very similar to SC20's VSCC. And then new this year, separate from the SCC, is the NDACC. And we'll be having the chairs of the NDACC, Arwa and Darshan, talking about that later. I'll give it back to you, Steve.
Thanks, Kathleen. So what's the process? To begin with, we've got a few months before the event, and this is the time to prepare. So teams will, in fact, already have formed partnerships with institutions and vendors. You will design a cluster, either a physical cluster or a cluster in the cloud, and you'll practice building and running all of the applications, or at least all of the announced applications on that cluster. One of the applications, of course, is a mystery app, so you'll need to practice just general building and troubleshooting skills. We'll have a series of webinars to help you prepare. So this one is the kickoff, of course, and there'll be one as soon as next week, in fact, which will be a deep dive into the Quantum Espresso application. So each of the applications and components will have some degree of a deep dive to help you get ready for that, as well as a few other sort of tips and tricks and logistics and so on along the way. The in-person teams, speaking of logistics, will need to consider the logistics of getting to the competition. So you will need to work out your own travel and so on. SCC provides conference registration for the in-person and virtual teams. That's for the 6 team members and an advisor. And for the in-person teams, SCC will also provide lodging. But we encourage your institution and vendor partners to budget for other expenses, things like food and travel and you're getting the equipment there for in-person teams. And finally, during the preparation, you'll need to build and install your cluster. You can bring it along with the operating system and everything you need already on it. You just need to assemble it at the competition. But before that, during the preparation, you're going to want to build and prepare that cluster so that you're ready to go when the competition starts. You'll also need to make a start on the reports that you'll be submitting as part of the competition, and also have your poster ready before the competition. So we'll have a few words on that shortly. So then when the actual contest happens, it will be very similar in some ways, similar sort of timeline, but slightly different procedures for the different competitions within it. So for the in-person student cluster competition, teams will arrive on Friday and Saturday. And then on Saturday afternoon, we'll kick off with some safety briefings and orientations. And then the building begins. For those who have been to one of these before, you remember that's quite an exciting and chaotic time of unpacking hardware and assembling things together and discovering what went missing along the way or has been delayed in delivery, dealing with all of the challenges that a real working HPC center needs to deal with to get the cluster up and online. So that will run through until Monday morning, and on Monday morning, the benchmarking session begins. At the end of the benchmarking, that locks in your final configuration. So during the benchmarks, you can make changes to what nodes you've got and how they're arranged together. But at the end of benchmarking, what you submit a benchmark for, the benchmark results for, is your configuration for the competition. On Monday evening, the benchmarking ends and the competition begins, or the main part of the competition rather. And at that point, the mystery app and the datasets for the other apps will be announced and made available. And so from there, it's Monday through Wednesday for 48 hours. It's go, go, go. Teams will run applications, gather results. Also during that, you'll present your lightning talks and posters. It will be very busy and exciting. Then at 5:30 on Wednesday, we'll have a little bit of a countdown leading up to it, and the contest ends. You'll need to have all of your results in by that stage. At that point, the committee goes into overdrive, checking and scoring the results so that on Thursday, we can announce the results of the competition. The virtual SCC is a very similar process, but it's very cloud-based. So you don't need to worry about travel in that case, but the timeline is very similar. So the benchmarking begins on Monday morning, and then on Monday evening, the benchmarking session ends and the main contest starts. The mystery app and datasets are revealed. And for the next 48 hours, you'll be working on running applications, gathering results, and also presenting your lightning talks and posters. That will happen, of course, in a virtual setting via Zoom or some similar platform. Also, Wednesday, 5:30, same time as the in-person competition, the virtual version of the competition also ends, and the results are announced on Thursday. So, some heads up about things, hardware, cloud resources, and software. For the in-person competition, we have some new power challenges. And I think Dan is online and can tell us a little bit about that. Do you want to say a few words, Dan?
Yeah, so one of the things, of course, that we have to think about with our systems is that they draw an awful lot of power. And for various reasons, we may not have that much power available in practice. And so this challenge is trying to capture some of that variable power that we see in modern HPC data centers when the power grid may not be able to go and supply what we need, or we have some other event that would require us to reduce the amount of power, the amount of cooling that our system has available to it. Thanks.
Thanks, Dan. And I know as somebody based in a HPC center in California that we've certainly experienced that in the last few years with public safety power shutoffs and limited power. For the VSCC element of the competition, there will be cloud budget. So you'll have a separate budget for the practice sessions and for the competition. And the competition budget particularly doesn't get announced until the beginning of the competition. So in your preparation, you will need to have some, what do you call it, multiple options and plans for what you will do with the budget that allow for some movement in what the budget is, or some uncertainty in what the budget is. So the elements of the competition for both parts of the competition, there are some benchmarks. The aim is to get the highest score on each of HPL, HPCG, and IO 500. So these are, actually, I think we might talk about those a little bit more in a moment. You have a series of applications. So most of the applications have already been announced. The one mystery application won't be announced until the competition, but you'll have a set of tasks to run with those applications. You'll run those tasks and report on your results and the performance that you achieved. There will be posters and lightning talks. You'll be presenting your team to attendees at the conference in the format of a scientific conference by giving a talk and/or by presenting a poster. One very important element is the reproducibility challenge. This is increasingly important across science at the moment, is the ability to reproduce results of published research. And so in the reproducibility challenge, you'll be working to reproduce the results of an SCC20 paper, and you'll be writing your findings in a report in the format and aiming for the kind of quality that gets published in journals. And that there might be some real world surprises along the way. So for instance, traditionally, there's usually been at least one power outage has happened for the in-person competition. And last year at the virtual competition, there was a last-minute change in the budget that happened in the last half a day that teams had to adapt to. And these are kind of representative of things that happen in the real world. So there are 3 benchmarks. LINPACK, or also known as HPL, high performance LINPACK, it solves LU decomposition. It's a very compute performance friendly benchmark, and it tends to highlight the peak performance of your system. And the annual, or actually, what do you call it, biannual, twice a year, top 500 is based on the LINPACK score. At kind of the other end of the scale, HPCG is a high performance conjugate gradient solver. And this one is much tougher. It's much more reliant on other elements of performance, such as memory bandwidth. And so while LINPACK tends to get you the peak of what you can perform at, HPCG is generally, most real applications will get a few more flops than HPCG will get. That tends to be a fairly tough one. And finally, the IO 500, which is an IO performance benchmark. And this is increasing in importance. So you'll need storage in a parallel file system in order to demonstrate some really good IO performance. The applications this year, we have cardioid. So all the applications are announced and have some details and links and so on the Student Cluster Competition website. So cardioid is a cardiac simulation suite, and it was a Gordon Bell finalist last year. So the Gordon Bell Prize goes to work that has done something significant at very large scale and kind of pushed the edges of high performance computing. So it's parallelized using MPI, and it has separate optimized loops that can take advantage of OpenMP, SIMD instruction sets for CPUs, or CUDA for GPUs. So you'll want to look at various accelerators for that. The other app is Quantum Espresso, which is a first principles electronic structure calculations code. So it's used a lot for material science. It uses a method called DFT. There's a webinar for that coming up Monday, June 28th from 1 p.m. Pacific time. So that's it's about 8 p.m. UTC, I think. But check on the website. You should have seen a notice by the same way that you got the notice about this webinar. There's an Eventbrite page for registering, and we'll send the Zoom link through that. So watch out for that. That will be very valuable to get more detail of how to build and run and what to expect from Quantum Espresso. The reproducibility challenge this year, the paper that we'll be attempting to reproduce the results of, is called A Parallel Framework for Constraint-Based Bayesian Network Learning via Markov Blanket Discovery by Srivatsia et al. You should either have or will soon have access to the paper by now. It's very important to read that. It's worth spending some time kind of understanding what they did, and we'll have some sort of practice data sets for you to work on that. And we'll have a webinar with a bit more about that coming up too. And then finally, the mystery app. So in building and running these applications, you'll be getting some experience in building and running applications for supercomputers. And you'll probably notice that there can be some sharp edges and challenges. The mystery app gets announced at the competition. And so in real time, on the fly, you'll need to work out how to build it and run it. So a good way to practice for that is general building and running troubleshooting skills. So we'll have a series of posters and lightning talks. Ben, do you want to say anything about these?
Yeah, sure. So like any good research that you do, eventually you want to get it published, and that publication comes presenting your work to audiences live when the situations allow it and there's not a global pandemic. So the goal excuse me, the goal of this is to oh my god.
Stop for a glass of water.
Worst time. Sorry. Yeah. Yeah. So the goal of this is to give you guys a simulation of that lets you present your work, get some feedback from other conference attendees, have them, ask about your work, get that experience of having your research critiqued in real time, which is always a exciting but sometimes nerve-wracking process. So we'll be asking you everyone to present some posters that talk about your team in school, your architecture, whether it be cloud or hardware architecture, and why you chose it, how you are managing your resources, again, whether those be over the cloud or physical resources, how you prepared, how you your strategy for running and optimizing the applications, and why you think your overall design will be the best. We'll be giving everyone more specifications on what those the poster and lightning talk will be judged on, and the sort of more on the format of those, but be prepared to be able to talk about your research.
Thanks, Ben. So for communications, there'll be a little bit more detail and links on this coming through very soon. Importantly, so teams will be invited to the students at SC Slack, and that's a good forum for asking questions from experts, each other, and the committee. What's very important is that all students and the team advisor do need to be on this Slack. So you will need to join the Slack and follow it, because we'll use it a lot for communication. So we'll be making announcements on the Slack as well as by sending emails. New communication mechanism this year, we'll have a Google document will be published, and that will be a place that will gather sort of FAQ type questions and answers, as well as announcements about each application and each element of the competition. So we'll have a kind of a centralized place where it's hopefully easy to find answers to questions that somebody has already asked. And there will be a Google group, but it will just be a do not reply list to get access to the Google Doc. So the Google Doc will be the primary place for asking questions, and Slack for kind of somewhat real-time communication, questions and announcements. So one more big new and I think very important element of this year's competition is we have a third contest, which is the NDACC. And I think either Awa or Darshan are online to introduce this to us.
Yes.
If you like, stay next when you're ready, and I'll step through the slides accordingly.
Yeah, thank you very much, Steve. So my name is Arwa, and I'll be talking through a couple of slides about the NDACC competition. In the slide, you can see the website where there are all the information about the competition, and if you have any questions, you can email us at that email. But the NDACC is a new student cluster competition in SC with more focus on education and supporting teams, especially the ones with not much vendor support or who are new to the competition and things like that. So if we go to the next slide, the timeline, you can think of it as a university course, a semester-long university course where you will have webinars, workshops to attend, and then after that you will be asked to submit some assignments, reports periodically, and this is throughout the months that are lead into the competition. So overall, we have 4 phases. We start in July. In the month of July, teams will get to familiarize themselves with the cloud resources, learn about the architecture of the cloud resource that we use in, and get to ask questions about that. And then in the second phase, we will be focusing more on benchmarks, especially HPL and HPCG. Then the third phase is when we experiment a little bit with the applications, and in a similar way to the SC competition, we will have a weekend to compete, so 48 hours straight, where teams will get new data sets and they will run with maximum throughput under a power cap, and judges will use performance and power metrics in order to judge the competition. So the thing is, like, the overall score for the teams will depend on the assignments throughout all the phases and the performance during the competition weekend on November 6th and 7th. So with regards to the application in the next slide, or actually more resources about the resources and hardware, we will be using Chameleon Cloud, and all the teams will have free access to it. So we sent out a request to fill in a form with the requesting information about usernames and all of that. So we asked the teams who are accepted to NDACC to go ahead and sign up there. And then we will continue setting your accounts up so that we can go ahead and start with the training in July. As I was saying, all teams will be given access to Chameleon Cloud, but they will be given access to the same hardware, so that everybody is having the same competing chances. So it's a level playing field, and there will be a combination of CPU and GPU nodes. Teams will not have an unlimited access to Chameleon Cloud. There will be actually a budget, and they will need to manage that on their own. So that's like part of the challenge as well. So we advise them to think ahead. And the other thing that is added is that teams will need to reserve the nodes for the competition time. And of course, all of these details will be sent to the teams in timely manner when they need to be done. So in the next slide, what teams gain from NDACC, they get free registration to the conference, and that includes full access to the technical program and workshops, as well as a complimentary one-year student membership to SIG HPC. The winner of NDACC will get bonus point for their SC22 SCC application. So they will have better chances of being accepted in next year's SCC. So to summarize that, you have free access to HPC resources, there are webinars and support from HPC experts, and you get feedback on reports submitted throughout the competition, hence improving your chances of being accepted next year. So with regards to the applications that will be run in the next slide, the benchmark will be using HPCG, so that's typical computational science kernel. And for the applications, we have 2 applications that are announced now, so GROMACS and John the Ripper, and there will be a mystery application. So for these, the first 2 applications, of course, in the 3rd phase, we will have webinars about them. The mystery application, it's more like towards the competition where you will get to learn about it more. And there will be, of course, webinars about all of these, and you will get to ask questions to experts, to application leads about these, like in the same way as SCC. So I think that is all we have in the slides for NDACC, and yeah, if there are any questions, I'm happy to answer them.
Thanks, Ara. So I see a few questions have arrived in the Google Doc. I don't think I've seen any arrive through the shortened link. So we'll run through these quickly. So will the in-person teams have any cloud component of the competition similar to pre-COVID? And I believe the answer is no on this one. Kathleen, would you like to?
Yeah, I can
confirm or deny?
let me take a few of these questions. So there is no confirmed cloud component for the in-person teams. This is subject to change, and I'll leave it at that. As for the second question, related to the hardware, the first question we have is, can we run benchmarks with extra GPUs and then get rid of them before the competition? The answer is no. Whatever you are running with the benchmarks, the point is for you to benchmark your cluster and then use that cluster for the competition. The second question we have also related to that is, are we allowed to power down individual hardware components to a lower power usage, not technically powered off? So what I would say here is that, think about if you're running a large HPC center. Are you able to do this without affecting other users who might be using the system, right? If you are not powering things off and other people are able to use it, then that would be fine. And then a question related to the VSCC teams. There will not be hardware locks, or we will not be restricting you to use the same hardware throughout the competition, no. Looks like we have a question about the reproducibility challenge. Limai, do you want to answer these?
I placed a link to the article there, but it seems that some universities can't have access to this. So I'll make sure that somehow that we can get it to people, or find a different way to get that paper in the students' hands. But the application, I've also linked the GitHub repo there. So I'll figure that out.
Yeah, so we can take those links and put them onto the main page, right? For the SCC website. That way teams who aren't looking at this Google Doc can have access to it also.
That sounds good.
That seems a good idea.
So let's see, there's a question about the NDACC. Arwa and Darshan, do you want to take that?
Hi, Kathleen. Yes, I can take that. It's a bit of both. It's more of a competition wrapped in a course style, since the focus is a little more on the education side of things. So that's a short answer to, it's more of a course than a competition. It's both. We will have reports due throughout the 3 months, but then a large part of the scoring will be that 48-hour competition.
Thanks, Darshan. All right, so there's a question about how many teams were selected for the 3 competitions. I don't think we're going to answer that today. The teams are published on the SCC website, the Student Cluster Competition website, not the SC related one, I believe. So you can take a look and see what teams are competing. Will SCC and VSCC rankings be separate? Yes, the SCC and VSCC rankings will be separate. We are planning to have a leaderboard for both of the competitions, yes.
Thanks, Kathleen. So I can see there's activity still happening on the document, but that sounds like the questions that we have so far are answered. We're getting very close to 12 o'clock and the end of the webinar. So we might have a couple more minutes in case there are other questions. But other than that, otherwise we'll sign off fairly shortly. And the recording and slides will be made available. We'll post either via the Slack or via email a link to where those can be found shortly. And the other important announcement is don't miss next week's webinar on a deep dive to quantum espresso. So you hopefully saw the Eventbrite sign up page for that one already. And input files for the cardioid app. Well, we'll have some deep dives coming up for that soon. But Yassi, do you want to say anything particularly about it?
I can take that question.
Yep.
So the cardioid application is available on GitHub. Please take a look at the GitHub repository, and related to input files, if you cannot find them in the repository, we will be having the webinar coming up, and so you can ask more questions and learn more details there.
I can see there's a few more questions and answers being written in the document, but we're getting close to the end, so we might stop here. The document will stay open for a little longer so that you can ask further questions and see further answers, and we'll capture those and make them available after the webinar. Thank you all for coming, and we're very much looking forward to the competition and working with you in preparing and participating in this contest. Good luck, teams.